Now we are going to start with the ionic bond formation. As you all know that how we make an ionic bond. So till now we have already discussed that like in ionic bond, what happens actually in it, transfer of electrons take place. We have already discussed that in this transfer of electrons take place. So that means there is an atom, right? Suppose this is my one atom and this is my another atom. So what is going to happen in this, one is going to lose electron, right, and other is going to gain this electron, right. So that means one is going to lose electron and other is going to gain electron. This is what we say the transfer of electron. This is what we mean by transfer of electrons. The one which lose electron, we know that is always metal, because metals actually have the tendency to lose electrons, and the one that gain electron is always a non-metal, because non-metal actually has a tendency to gain electrons. So we can say that ionic bond is formed between metal and a non-metal, right. So now we are just looking for the factors that actually you can say that actually enhance the ionic bond formation, that actually just govern the ionic bond formation. So what actually happens, we will just see with an example, general example, that what actually happens in the ionic bond formation. What are the steps involved, right. So the first step is that we need to convert metal which is in solid state, right. We have a metal which is in solid state, we need to convert in a gaseous state. We need to convert in a gaseous state, because whenever we are adding an electron or whether we are extracting an electron, it is always done when the atom is in gaseous state, right. So here we are it is going to lose an electron, so we have just started with the metal, right. So we are just going to convert this metal from solid state into gaseous state, and this step will actually require the energy, you know that. So let's say that this step requires the energy called as delta H positive, and what is this energy called? It is called as sublimation energy, or right. So this is what is going to happen. Then in the second step, what we will see that this metal in gaseous state is going to lose electron, right, but it is not going to lose electron as such. It is not going to lose electron as such. We need to supply it with energy from outside. We need to supply it with energy, and that energy is called as ionization energy. That energy is called as ionization energy. So I'll write here again, we need to supply it with energy. Let's say H is positive, and that energy is nothing but ionization energy. That is the amount of energy actually required to remove an electron from outermost shell of an atom. So this is what we have done. Next, in third step, what we want that our non-metal should accept the electron, right, and after accepting it will acquire a negative charge. Now in this case, in third case, what is going to happen, when we are adding an electron, it will release energy. It will actually release energy, and so that means here the delta H is going to be negative, right, and this energy is nothing but electron gain enthalpy. It is electron gain enthalpy. So this is what we have. Now as we have the metal ions and we have the non-metal ion, now they are going to combine with each other, right. So just let us combine them. So that means this is my metal and this is my non-metal, the one which has lost the electron, the other which has gained the electron. Now when they will combine, they will form a lattice, because see they are oppositely charged, so they will experience a Coulombic force of attraction. They will experience the Coulombic force of attraction, which can be given by this, as you know in physics. We need this is a Coulomb's law, which actually states that how the oppositely charged ion gets attracted towards each other, right. So that means they have the Coulombic interaction, attractive force operating between them, and due to which they combine to form 1 mole of ionic compound. So this is my 1 mole of ionic compound. So in this state, when they combine with each other, it leads to the release of energy again. And this energy, that means, is negative, and this energy is nothing but a lattice energy. It is lattice energy. So overall we have seen that in two steps actually what we did, we supply it with energy, and the last two steps the energy is released. And we know that energy is considered to be a stress factor. More is the energy released, more is the stability. That means when a molecule will possess less energy, then it will have a more stability. Or you can say more is the energy released, more stable is that compound is going to be. Right. So in this case, that means suppose I say this is X, this is Y, this is Z, this is my A. Right. So in this case, the Z plus A should be greater than X plus Y. That means the energy released should be more than the energy absorbed. Then only this ionic compound is going to be stable. So if somebody asks you about the factors that actually influence the formation of ionic bond, you are going to say that we need a metal, like if we are talking about metal, we need a metal which has the low ionization energy, means that it can give the electron easily. And we need a non-metal which has high electron gain enthalpy. That means it is going to release more energy. Right. And likewise, when they combine with each other, they should have more attraction. That is why you will get to see more lattice energy. So this is also released. This energy is also released. So the release should be more than the absorbed one. Then only our compound is going to be stable. So that means the factors which actually stabilize the formation, or you can say influence the formation of ionic bond, is the low ionization energy of metal. Second is the high electron gain enthalpy of the non-metal, and the high lattice energy of when they combine with each other. Right. Now you know that, like if somebody asks you about the correct definition, for technical definition for lattice energy, what you are going to say? You are going to say that lattice energy is the amount of energy released. I repeat, it is the amount of energy released when the positive and negative ion just combine to each other to form 1 mole of ionic compound. So that means lattice energy is, again, it is the amount of energy released when the positive and negative ion just combine with each other to form 1 mole of ionic compound. So that means in this, the delta H, that means the lattice enthalpy is going to be released, so delta H is negative in this case. Right. So sometimes what you have seen, like you may have encountered a term lattice enthalpy also. So maximum of you, like what you think, that you say that lattice energy and lattice enthalpy both are the same things, but it's not like that. Lattice energy and lattice enthalpy are two different things, right? Though they have a you can say a similar meaning, but still there is a difference that exists. So I'm just trying to show you that difference. See, lattice energy, suppose I'll explain you with one more example. Suppose I have this ionic compound, right? So when this ionic compound is formed, that means it must have formed from this thing. So when this ionic compound is formed, the energy was released, and this energy was nothing but lattice energy. So that means here the delta H is negative, right? Now I have this compound and I need to break this compound back into the gaseous ions, right? So I want it to be split into again the positive and negative ion. So in that case, I have to provide it with energy. I have to provide it energy so that that energy can you can say break the attractive force, right? And that energy is something called as the lattice enthalpy. That energy is called as lattice enthalpy. So that means, we can say that delta H for lattice enthalpy is positive. So lattice energy is actually energy released when positive and negative ion just combine to form 1 mole of ionic compound. And lattice enthalpy is the energy needed to be, when we need to break the bond, right? It is the energy needed to break 1 mole of ionic compound back into its constituent ions, right? So then we can say that lattice energy is plus delta H and this is minus delta H, because the lattice energy is delta H positive, delta H negative because it is being released, and lattice enthalpy is positive because you are supplying it with energy. So this is what is the ionic bond, and this is what are the factors that actually influence the formation of ionic bond. So if we want to sum up the you can say the properties of the ionic compounds. So we can say that first they are solid, they are solid actually. The reason behind that is because they have a strong Coulombic force attraction between them. You can see that because it is formed by between positive and negative ions, so obviously they have a strong attraction, right. Second thing is that because they possess strong attraction and there is a definite arrangement actually in a crystal lattice. So they occur in a special crystal lattice, they have a definite pattern of the arrangement. Third, because there is you can say attraction between them, so that is why their melting and boiling point is high, right. Because they possess ions, so that means they are good conductor of electricity, right. As you can see the ions, so this clearly indicate that they are soluble in a polar solvent, not in a non-polar solvent, right. And because they possess the ions, so obviously they will undergo a ionic reaction, and you know that the ionic reactions are very fast, they occur very you can say they occur very soon, like as you mix them it occurs in a short span of time. So these are the few you can say the characteristics of the ionic compound. One is that they are solid, second they arrange themselves in crystalline structure, third they have high melting and boiling point, fourth they are soluble in the polar solvent, fifth they are good conductor of electricity, and last but not the least that they show ionic reactions which are fast in nature. So this is what we have seen, that this is the ionic bond formation and the factors that influence it actually.